In this video, we're going to explore the volume of prisms and cylinders. But before we do that, we have to discuss what volume actually is. And volume, as a traditional definition, is the amount of three-dimensional space an object will take up. Well, what we have to really think about volume, though, is there's a connection to area. And volume, for our purposes, is going to be an accumulation of area. So if we take little thin slices of rectangles and we were to stack them on top of each other, eventually what we would get would be a rectangular prism. So we're going to explore this little diagram here in depth. I want to take a look at this one here. And so this is our little sketch, and we have right here a rectangular prism with a height of 0. So essentially we just have a rectangle. What we're going to do is start adding on to this height, and what will happen is we'll create a rectangular prism that will now have a volume. So as I drag this up, think about each little piece that I add here is adding on little thin slices of rectangles on top of each other. We're stacking those up. So as we add more and more area, what we end up getting is volume. And it's the amount of three-dimensional space that this object is going to take up. In this case, it's a rectangular prism. Now, works the same no matter what type of prism we actually have. Whoop, sorry about that. So if we have a rectangular prism, triangular prism, or anything else, the same basic concept still applies. Sorry, that got in the way there. All right, so when we have a triangular prism, we're going to look at a little different sketch to see how that will appear. But essentially, we're going to have the same basic idea. So let's load this guy up. And in a triangular prism, we know that our base is a triangle. Depends on what type. It might be a right triangle. It might be isosceles. It might be equilateral. We're not really sure. But if we view from the section, if we change this height here, we have our little plane that's crossing this triangular prism. You notice that wherever that plane crosses is going to form that triangle. So if we start stacking these on top, so if we start here at the very bottom, we've got our base, and we can start stacking triangles on top of each other. What we end up getting is a volume. It's an accumulation of area. If we were to view this from the top, it would look something like this. And again, our height, as we change it, it really doesn't change much. We're still stacking those triangles on top of each other to give us our volume. And it works the same with cylinders as well, but now our cross-section is going to be a little bit different shape. So we load this guy up. And because I'm dealing with a cylinder, my cross-section is now a circle instead of a triangle or rectangle or any other shape. It's just a circle because of the cylinder shape. So again, similar idea, I can just kind of move that along, and I'm stacking circles on top of each other until they accumulate a volume. And looking from the top, we can tell what that base will look like. So when we're dealing with cylinders and prisms, the reason we're covering these together is because they have the same basic property of having two bases. If you have two bases, the volume of the prism or cylinder is the area of the base, or one of your cross-sections, they're identical, times the height of the object. So it's the area of the base, and we're going to use this capital B to distinguish that, times height. Now, the height is the length of the segment that connects the bases. That's key, because it doesn't necessarily have to be vertically oriented. It could be horizontal, but the height is still the segment connecting the bases. So we're going to try a couple problems with this. Where appropriate, we're going to leave our answer in terms of pi. Where appropriate, we're going to include units in our answer as well. And we're trying to find the volume, not the surface area, but the volume of these figures. So the first one I see here is a rectangular prism. And we can think back to that diagram that we had where we had the rectangles and then we just stacking them on top of each other. In the surface area unit, we talked about that a rectangular prism doesn't really have a base. But for our purposes with volume, that's okay to think of that because the rectangular prism is sitting on something. Clearly in this diagram, it's sitting on a rectangle that's 5 by 11. So if we start thinking about this as being the area of the base of 5 by 11, then the height would be this 6. So the volume is going to be the area of the base so that's what this guy right here is, times your height, which is 6. So when I multiply 5 times 11, I'm going to get 55. Oops, I don't know why that didn't change colors. Let's try that again. All right, red, there we go, times our height. So we're going to multiply that by 6, and we end up getting 330. And again, we have units given to us. Unlike area, now we have cubic units. So area, we talked about square units. This is cubic units, 3 dimensions. Number 2 is a cylinder, and the area of the base is just going to be the area of the circle. So we're going to use that formula, area of the base times the height. So the area of the circle is pi times 5 squared times our height, which is 10. Oops. And so we're going to multiply 5 squared and get 25 times 10. Better close those parentheses. Times 10, which would give us 250 pi centimeters, that's our units, cubed. In 3, we have a hexagonal prism, so we have our hexagon bases. And our strategy for finding the area of a hexagon was to break it up into 6 triangles. So I'm going to do my best here to make this actually work. All right, so that looks pretty good so far. And pretty close. Okay. So what we end up having here is 6 equilateral triangles. All of them are going to be the same. So we have a side of 2 for the base. Now, when I'm going to find the area of the base, I know there's 6 equilateral triangles. And each one, we can use the formula 1/4 side, which is 2, squared, root 3. So 2 squared is 4, and 1/4 of that is 1. So it becomes 6 root 3 for the area of one base. But for the volume, we're going to take the area of that base, and we're going to multiply it by our height, which in this case is 5. So the volume is 6 root 3 times 5, which will give us 30 square root of 3. And again, our units in this case are feet, so cubic feet. And in 4, our last one that we're going to look at in this video, we have a triangular prism, and we have the base as a triangle. And so I'm going to just kind of highlight where that base is. It's this guy right here. And we have one on the other side that's identical. We're not worried about how many bases we have. We just want to know the area of that base. Noticing the sides, I've got a 3, a 4, and a 5. That sounds like a right triangle to me. So my right angle would be there. So the area of my one base would be 1/2 of 3 times 4, which is 6. And then I multiply by the height, which again is the segment connecting the bases. Even though it doesn't look like a height, it is. So our volume then would be 6 times 11, which gives us 66 cubic centimeters. Okay, and that's how we deal with volume of prisms and cylinders, is we want to find the area of one base and multiply it by the height, which again is the segment that connects the two bases. And it's just an accumulation of area.